Our speaker tonight is Haydon Bailey, who's come all the way from St Albans to speak to us about the geology of the Chiltern Hills. He's lived there for quite a long time in the St Albans area, and his background, going back many years, his original degree was at Sheffield. He then went on to do a PhD based in Devon at the University of Plymouth, and then from there moved into work, or the title of the PhD I think was looking at microfossils. Cretaceous microfossils. And he's basically worked in micropaleontology ever since. Had a very long career in micropaleontology, mainly in the UK, and has spent quite a lot of time doing research. And also, he's been the past president of the Geologists Association from 2014 to 2016. And since retirement, he's still working. He's still very heavily involved with the GA. So this is Haydon, and if you'd like to start, we haven't got the screen up and running yet, but
I'll fill in a little bit.
Okay.
Thanks very much, Alan. So, yeah, as Alan said, I worked, my PhD based down in Plymouth was on Cretaceous micropaleontology. For those of you that know the geology of Devon, and I'm sure you do, there is very little Cretaceous in Devon. There's a bit of chalk across on the southeast corner, and that is it. So it came as a surprise to me when I moved up to Hertfordshire and started digging the garden over, that I started picking up fossils that I recognised in the back garden in the first place. And I started to get involved in the local geology back in the late 70s, early 80s. And effectively, it's gone on since then. I'm still involved, and probably I used to start some lectures with a picture of my father in memory of him, because my father's motto through the whole of his life is never volunteer. And he only volunteered once, and he said he ended up 3.5 years in Egypt, and he didn't want to go. And in fact, what we found was basically back in 2008. I've been a member of a local organisation called the Chiltern Society. I've been a member of that for several decades. Basically, they're people who do a lot of conservation work in the Chiltern area. And 2008, with my annual membership fee, there was a little note in there saying, please inform us if you've got any background that might be useful to the society. And this is where my father's don't volunteer would have come in very, very handy, because I just put in there, I'm a chalk geologist. And it took probably less than 3 days for the phone call to come through. And a guy at the other end, very nice chap, said, we've got a river that keeps disappearing. Can you come and tell us why? So I said, well, we'll have a look at it. And this was the River Misbourne, which flows from Great Missenden down to Denham, near where the M25 goes through. And I had a look at the River Misbourne, and I was surprised there was a river there at all. The chalk underneath it is completely, I think, cream crackered is the polite way of putting it. So I wrote a report for them, and I got a phone call about a week later from the guy who was chairman of the society saying, would you like to be the geological advisor to the whole society? And I said, well, I thought you got one because there was a guy listed. He said, no, he's just died. So I said, right, okay. So is this a job for life? He said, yep, okay, you're on. And I said, is there a job description? He said, not until you've written it. So since 2008, I have been the geological advisor to the Chiltern Society. It's got a membership of about 7,000 people, so it's there is a lot of it's quite interesting inquiries come in, and it was fine until 2010. First 2 years it was a doddle of a job, and then 2010, somebody in government decided that HS2 would be a good idea, and for the last 14 years, myself and 4 other guys have been doing everything we can. We're currently at the monitoring stage, but we've been through the House of Commons, the House of Lords. It just went on and on. So yeah, let's just see let's see if we can get in here. 2 other quick adverts while I'm here. If you've not seen this before, Hertfordshire Geology and Landscape. If you're interested in basically the geology of southern England in any way, this is an immediate go-to. Okay, it was published in 2010. It is still one of the best go-to books in terms of regional geology in the country. So I've got 1 copy with me, but there are other copies available, just a few. The other thing I'm going to advertise, one of my jobs at the GA, I run an initiative called School Rocks. And School Rocks, basically, we just try to put rocks and fossils into the hands of as many school children as we can, particularly those schools that don't have any resources at all. We provide them with lesson plans so they know what they're teaching and they've got the specimens to go with it. We've just started a course. The rocks and fossils, particularly in primary schools, go to year 3. So if you know anybody who's got kids who are 7-year-olds, or any teachers who teach 7-year-olds primary school, then School Rocks is just what they need, because they have to teach rocks and soils in year 3. So that is key. But in year 6, so the 11-year-olds, they have to do a course in evolution. And we've just put together boxes which contain a series of horses' hoofs and micraster echinoids, and we put the lesson plans, and there is a workshop that goes with it. So we are now supplying, or in a position to supply, the evolution boxes for year 6s. So if anybody is interested or know any kids the right age or whatever, then pick one of these up on the way out. The email address that's on there, School Rocks at the Geologists Association, comes straight through to me anyway. So I would pick it up. Okay, but if you need any information on it, then see me about those. Thank you for listening to all the advertising. Now we get on to the serious matter. The title, Geology of the Chilterns, New Data, New Interpretations. When Alan originally contacted me and said, could I come up? And I thought, well, Owen, yeah, I'm sure. I'd just been contacted by a local river society, the Ver Valley Society in St Albans, to do a talk for them. And I told them initially, I said, you've heard what I've got to say about the geology before. I haven't got anything new. But then I thought about it over the next week or so, and I contacted the chairman there, and I said, John, actually there's a hell of a lot of information that's coming out at the present moment, so I'll put something together. And this is a sort of follow-on from that. So it's recent and ongoing geological work in the region. You'll see that the Geological Survey have been very active in the Chilterns since around about 2015. And this is work that was originally planned back in the early 2000s, didn't happen because the BGS hadn't got any money for mapping. And it wasn't until the Environment Agency, who thought the water companies were trying to pull the wool over their eyes, said, okay, we need an independent opinion, so we'll get the BGS to do some work. So a team led by Andy Farrant, people like Mark Woods, Rian Kendall, did a fantastic job. And they started systematically working from the southwest, looking at all the river catchments and working northeastwards through the Chilterns. They started down on the Misbourne Valley, which is the river that I started on in 2008. And here's the route of HS2 coming through. So it goes smack through the Misbourne Valley. Other things to pick up on here, which we'll come back to. One is this little dotted line through here, which says pre-Anglian Thames coming through here, and then the Anglian ice limit. So in Anglian times, which was 475,000 to 425,000 years ago, this was the limit of the glacial ice sheet that came down into southern England. That had the impact of hitting and blocking this line of the River Thames. It turned it round and eventually forced it onto the line of what is the modern day Thames. So we've got quite a history in the area, and that comes into the story that we've got. So as a result of the work that the BGS did, 2000, and in fact they have still been doing bits and pieces over in this northeastern corner on some of the rivers, like the top end of the Cam, the River Ree. That work is still ongoing, but they've been producing a whole series of reports during the sort of mid-teens. So from around about 2016, 2018, I think that was a 16, that was an 18 report, which goes with the digital model for the geology of the Chilterns. So it is really very, very useful. And so for people like me, it's been great to sit in on the back of this. And I did some of the field work with the BGS when they were in the field. So it was really good to work with them. The area that they did around, sort of, there's St. Albans, where we've come up from. Ignore the misspelling of Berkhamsted. The BGS obviously can't spell. This is one of their slides. We've got catchments like the River Ver, the River Gade, the Bulbourne that comes down here. I shall also talk about this area down in the southwest around the Chess Valley down here. So a lot of work has been going on, and our understanding of the geology of the area has been evolving really quite quickly, especially for geologists. You know, that areas that we thought we knew, this was well established, nothing happened in the chalk. Then we're beginning to see there's actually quite a lot more going on than had previously been recognised. The first thing I will just do this really quickly so we cover it. The old traditional chalk stratigraphy used to be the lower chalk, middle chalk, upper chalk section. Back in the 1980s, Rory Mortimer down in Sussex did this huge amount of work on the lithostratigraphy of the chalk, recognised 9 different formations. I think it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 formations. All the markers, a lot of these markers we can actually pick up right up through the Chilterns. So some of the important markers, if things like the Caburn Marl, the Southern Marl, the Glyn Marl, all these marls through here, although they were described down in Sussex, we can actually find exactly the same marl seams, and we can place ourselves very well within the stratigraphy. So the section we're going to be looking at is not the whole thing. We're going to be dealing with this bit in here. So the youngest levels we get in the Chilterns are really around this level, what we call the Seven Sisters Flint Band, from the Seven Sisters Cliffs down in Sussex, then down through to around about the level of the Plenus Marl. We won't be getting down into the Plenus Marl in this talk, but certainly into the New Pit chalk and the Hollywell chalk. Those are some of the sections that we are now recognising quite easily on the basis of Rory's definitions. Now, one of the places that the BGS had not been into before they did the mapping in the area was this place, Kensworth Quarry. I'd been going into Kensworth since about 1978, 1980. So because I was on first name terms with the quarry manager, the BCGS, would you like to come and, by the way, get us in as well? So this is probably the largest working chalk quarry in England today, or the UK for that matter. It is really quite significant. It's much bigger now. It's been driven through quite deeply. You'll see some of the photographs to get some idea of the scale. Probably just less than a mile long. In the centre there. When I've led field trips to this place in the past, one of the questions I've always said to people, can you explain how, I think it's 8,000 tonnes a week comes out of the quarry, and there are no lorry movements out of the quarry whatsoever. It's all done by pipeline. And you can see that circle there is when they turn the chalk to a slurry, and you can see a slightly lighter bit of grass through there. That pipeline goes out there, goes 90 kilometres up to Rugby, to the cement works in Rugby. So it's quite an amazing place to be able to work. This is the size of it in terms of, I always put this one in because it's lovely. You've got this lorry sitting here, just about to see it. The tyres on that are almost 2 metres across. So that gives you some idea of the scale we're working in here. As I say, it gets to be around about 60 metres of chalk down at the bottom. And what I'm going to do in the first part of the talk is just take you through some of the things we've learned about chalk in the Chilterns by looking at this quarry in some detail. Okay, it's not the easiest place to work. We used to have students from Birmingham logging through this section and collecting samples, and you need at least 3 people to log the section, otherwise everybody gets lost on different benches. It's really quite difficult. So what have we learned from Kensworth? One of the things that's come out over the last 10 years, the chalk has got a karst topography. And if you know, basically you know in Carboniferous limestone you get all the cave systems, you get a typical karst topography. Well, the chalk is riddled with holes. It is seriously eroded away. Some are backfilled, some are open, but a lot of them, they go back to that Anglian ice age that I mentioned earlier on. It had a huge impact in the Chiltern Hills. To give you some idea, all these brown patches through here are clay filled, or they sort of sediment filled pipes down at the base of the quarry at Kensworth. Now if I say they're at the base of the quarry, that means they're about 55 to 60 metres down. That means there are pipes going back up to surface, that length, filled with sediment, or not, or open in places. And to show you, that's one of them. That would be about just a metre, metre and a half in height. I haven't got a hammer on that one. But on some of these others, these are all sediment-filled pipes. You can see this chalk mass. This where the roof has started caving in. All these clay-filled pipes occur at the bottom of the quarry. So we know that those clay pipes go all the way down. We also see clay pipes at the top of the quarry. So these are the things that have been feeding the pipes down. So the whole of that chalk, even though it's a nice pure chalk from a quarryman's point of view, getting it out for the cement works, there are impurities in it which go all the way through the sequence. So what we've learnt is the chalk through the Chilterns actually has got holes in it, big time. We sort of suspected that anyway, but now we've been able to prove it. But just to show you a few more up to date, this is how HS2 has come through, and we've had sinkholes because of the tunnelling. Some of these got into the press. Just to give you some idea, these are the lines of the routes of the tunnels going through. The pink bits are where the 2 tunnel boring machines were at the time back in May 2023. The lake behind is a lake called Shardlows Lake, just north of Amersham. in the Chilterns, and that's Shard Lows on the sort of the overhead photo there. Fortunately, the sinkhole went here as this machine was going through, and not another sort of about 500 metres further on. Otherwise, the River Misbourne would have been going straight to the sinkhole. That's now been backfilled, but subsequently we've had a couple of more sinkholes. You can see where this one's opened up. There's a bridle way through here, so the horses would got out of the way. This was in February this year. That one opened up, and then a week later, this opened up effectively about 100 metres away from where this one had just been backfilled. I suspect they're actually still they're all part of the same erosion system. I think these sinkholes connect up. But I'm still waiting. I'm in discussion with the guys at HS2 to see if they are. Where these took place was about 150 metres short of this, which is where the tunnelling machines came through at the end of March. So this is fairly recent, where they completed the two 16-kilometre tunnels underneath the Chilterns, so underneath the Misbourne Valley, from effectively the M25 at Denham right the way up to Great Missenden. So these are now being taken apart. The tunnelling machines, the TBMs, were about 160 metres long when they were actively working. They're now being stripped down, and anything that can be reused will be reused, but the rest of them will go to scrap. So we've learnt that it's got a karst topography. One of the things I always say to people, if you look at the Chilterns in detail, you'll find that one of the youngest bits of chalk at the top of the escarpment is what we call the chalk rock. I haven't brought a lump of it with me. I frequently carry lumps of the chalk rock just to prove it. But it's actually very holy when you look at it. When I say holy, I'm not talking in the religious sense. This is chalk rock at the top of there's Kensworth Quarry in the background, but this is some of the chalk rock, which is, okay, in old chalk terms, top of the middle chalk. So it's top Turonian, late Turonian, about 90 million years. And because of the complex sedimentation at that time, we end up with this mineralized, extremely hard layer in the chalk. As I put here, water's going to pass straight through that fairly easily. It's actually also micro-fractured. So as well as the pipes that you get going through it, you also get lots of micro-fractures. And any water going through this will then sink through into the formation below, which is called the new pit chalk, and the new pit chalk is characterized by having loads of marl seams in it. And if you get a marl seam, water doesn't like going through marl. It can't get through it very easily in the clay, so it goes sideways. And that's why those those sort of pipes that I was showing earlier on were sitting on top of marl seams, because the water's come down even 60 metres, hit a marl seam it couldn't get through, and has gone sideways. So we know that the chalk rock is developed at the top of the escarpment. It's also extremely hard. It's mineralized. I've just put these in. You can see the glauconitization there. There's a nice solitary coral in it. But this is, and you can still see burrow systems running through it here. The chalk rock is a real complex. To call it a lump of chalk is a misidentification. If you hit it with your hammer will just bounce off. It's not a soft chalk. It's not like the Seaford chalk sitting on top of it, which is nice and soft and your hammer sinks into it. This stuff, when you hit it, your hammer really does bounce. The other thing we've learned, there are faults around Kensworth that we weren't aware of before. And if there are faults, there are going to be quite a lot of fractures developed with them. So it's worth having a look. There's that photograph of Kensworth again, taken back in 2012. This is 2014 in the spring after we had, I know we've had a lot of rain this year, but we also did 10 years ago. I don't know if you calculate your sunspot cycles, but that's what we were looking at in 2014. That lake is about, it's just short of 1 kilometre long. And in some places it was a good 13 meters deep. So that water is sitting on top of the chalk at the bottom of the quarry, which is the new pit chalk, which has got clay seams in it. So the water can't get through very well. So it builds up, and that was in there for a good couple of years. But with the BGS mapping, where I've just put those in, they recognised there were faults there. There's a good fault system running down through the south, and there's possibly a few more over here. This is the one in the southern end of things. You end up with over a 20-metre stretch, probably just a mush of broken up chalk. You don't see a nice clean fault line. It is literally just 20 metres of mush, and you know that the chalk on one side is different to the chalk on the other. You do get some places where you get a clear fault. That's probably because that's up at the level of the chalk rock, so the chalk is much more consolidated and gives you that sort of nice break to see. This is also one of the benefits of HS2 coming up through the river, the Misbourne Valley. This is one of the cross sections through the geology where the tunnel was put through. I'm not going to go through it, there's far too much information, but you can see there's a lot of boreholes through it. They drilled so many boreholes you don't want to know. That is a complete lecture in itself. But if you follow this line through, that's the roof of the tunnel coming through. And what I want to try and pick out is these dashed red lines. That you can see there's two there. That's actually underneath that lake I showed you earlier on. The red lines on here, all these are fault lines that have now been recognised because of the tunnelling. We know that the Misbourne Valley is actually riddled with faults. If you go to the existing published BGS map for this valley, which was published in 2005, there are no faults whatsoever. Just on the tunnel route, that's 16 kilometres, over 50 faults have now been recognised. So we know that the structure in the chalk is far more complex than was previously recognised and mapped. Okay, so we're learning this all the time. So it is one of the positive impacts of HS2 that we know there's a lot more structure in the chalk. If there are faults in there, we know there are loads of fractures. This is in the new pit chalk formation down in Kentsworth Quarry. You get all these very high angle fractures running through. When I show you a face like that at Kentsworth, this is on a wet day, you sort of start to say, well, can we actually see any? Just out of interest, I recognise the jacket. For those of you who are members of the GA, as of May this year, that is your new president, Liam Gallagher, who's worked on Kentsworth with me for the last, 30 years. Let's have a look at it, see if I can put any sense onto this. 2 marl seams running through there. But in marl seams, we also get a whole series of joints running through here. And through the new pit chalk, you can see these high angle joints going through. That is where the water flow really gets going. Joints don't like marl seams. Frequently, they will stop close to where the marl seams go through. So jointing is really very important within the chalk and the permeability of the chalk. That is where the water flow really comes in. Now, Rory Mortimer, who I said defined the lithostrat, the formations, back in the 80s, Rory did a fantastic publication back in 2012, which all it said was, all I need is a joint log or a fracture log. And he went through and calculated the number of fractures you would expect to see in each formation per cubic meter of chalk. So you can look at things like the new pit chalk that we were just looking at, and he would anticipate you should be seeing 4 joints per cubic meter. And I did one bad afternoon once try to calculate how many fractures 2 tunnels going through HS2 tunnels would have actually cut through doing 16 kilometers, and it came to something like 21 million. So the amount of fractures that have been cut through, you imagine what it might do to the flow of water through the aquifer there. But okay, there's the chalk rock where the microfractures. This is the sort of detail we now have available on individual formations. So it's really, really useful. So we've done all that. What else have we learned? One final thing. Chalk at Kensworth is bent. I've always, when I first started working on the chalk, it was just a nice sort of low angle dip of about between 5 and 7 degrees to the southeast in towards the London Basin. That's what we thought. One day I was walking across the quarry, and I think it was about 2012, 2013, before it flooded. And I was actually I'd left a crowd of guys working in the quarry, and I was aiming to go back home. And as I walked back across the floor of the quarry, I thought, I can see a low angle fold in that. There's an anticline in here. But then it was flooded for 2 years, and I thought, well, nobody's going to believe me anyway. And then the BGS came up, and I went up there with the BGS, and I said, do you think the chalk's got any folds in it? They said, oh yeah, definitely, we've seen them all the way through. Now you tell me. So believe it or not, you can just pick out the bedding, but there is actually a really low angle anticline going through there. I'm not going to ask you to believe it from the photograph. It's just you do, but it's when you actually walk it, and you can see, you think, yeah, it's not playing me for a fool. I can actually see that there is a dip and a closure over within the floor of the quarry. And subsequently, there's Kensworth. There's the line of that fold. The BGS have now recognised a whole series of folds. Here's St Albans, where I live, and this is the ripple effect in the Chiltern. There's a whole series of anticlinal folds and corresponding synclines as we go through the chalk, and they all trend northeast to southwest. So not only are we recognising a lot more faulting, we're actually seeing some really subtle folding in there. So this does have an impact on how the chalk behaves, and I'll pick up on that as we go through. Within the Ver Valley, which is up from St Albans is about here, there's that's Kensworth with the faults running through northwest to southeast. There are some lines of faults which almost parallel where the folds go through. There's another possible fault through here, a place called Redbourne. Anticline just north of St Albans, that's anticline south of St Albans, bit of a syncline in between the two. The reason I've picked this one out is that years ago, I logged the section at a little quarry called Redbournebury. This is the section, and it's published in the Hertfordshire book. And we've got samples from micropaleontology. We've dated it. We know what age it is. And in fact, if I take it there's a tiny little fossil. I think I'm going to love these are the pronunciations that I have fun with. Stenzoina granulata levis. It's a key stratigraphic marker in the micropaleontology across Europe. Okay, levis means to me, okay, my Latin is non-existent. It's bald. It doesn't have any ornament. The species, it says granulata, should have a nice granular ornament. This one is bald. its levers. And it came from that level, which is the top rock, which is the final sort of hard layer above the chalk rock. And it came from one of the burrows in there. It's the only occurrence of that marker species in the UK. And it came from that pit just north of St Albans. So it's quite important. It gives us an accurate date of when that sort of level of transgression of flooding across the chalk surface through there. There's Redbournebury, that quarry I've just shown you, that's the tape there. Now about 15 kilometres away to the southwest, there's another chalk quarry called Springview. You can actually pick up a sort of strange sort of orangey colour through there. It's another one of these hardgrounds, a bit like the chalk rock, but that up there is that one, and it's effectively the highest one. It's all bound up in one layer of hard ground called the top rock. When I logged these two sections, you can see where the samples came from. Again, we looked at them, we dated them, and it seemed that that 11-metre section there was disappearing into this gap. Couldn't really work out why. But now that we've got this structure that we begin to see, we know there is faulting going on, we know there is folding going on. So it may be that the loss of section that we're seeing, it may be explained partly by the gap. We've got a 6-metre gap in section there. It may be that it's close to the anticline and that might be cutting something out, as might that Redbourne fault through there. Or it could be something else. The thing I've always suspected, and I've never been able to prove, but we're looking at, is if you look at this, this is just purely sedimentation. This is in the chalk on the North French coast. And you can see how sections are being cut out by the way you're getting these sort of wedge-shaped erosive surfaces coming through here. So we may be looking at, if you like, a small-scale surface such as that. Now, just to show you, again, as a local society and you're looking after local sections, the Hertfordshire Geological Society, back in March last year, we went into this small chalk pit just to the west of St Albans. Nobody had been in for years. It was really grim in there. It was totally overgrown. But there is a bit of a chalk face. The BCGS had been in and mapped it. And I was curious because you get these oddball flints, which we call carious flints. Carious flints are flints that don't completely silicify. So you get an outer, if you like, cortex of silica, of flint, but the inside is just a soft, powdery mush, if you like. It's been partially silicified. But when you actually look at what's inside the flint, and if you were to take a sample of the chalk immediately outside the flint, as a micropaleontologist, what I see, the two samples are very different. It's really something which is very, very odd, and we've never fully explained it. Just to prove this, this is Potter's Crouch pit. Potter's Crouch sample PC1 was from the inside of the flint. PC2 came from immediately outside the flint. Now, they're just a series of dots to you, but you'll see that the little dots in this one, there's loads over on this left-hand side. You compare that with this one, it's really not as much at all. We get a totally different microfauna inside the flint compared with outside the flint. This is an ongoing, it's just as I say, we've never got a proper explanation. We have some ideas. But the one thing I want to pick up on here is this thing. You think, wow, that's a nice pretty one. Well, this is a thing called Margino-Truncana schniganzi. And again, it's a key global stratigraphic marker. It's never been recorded in the UK prior to us going into this pit. But, I don't know, it came from the flint meal. There. Oops, let's go back. And that big specimen there, big to me, it's about 0.5 millimetre max, is one of these. It's the first time that we've got a global marker coming out of the UK chalk. So there are still things to be found. So it's not been written up yet. It's one of the things that we've got to go back and measure the section properly because we're not happy with currently where it fits in the stratigraphy. But that is an ongoing bit of research that we're doing. So I'm trying to do this whistle-stop tour of research that's going on in the region. And a couple have said to me already this evening that Hertfordshire to them means Hertfordshire pudding stone. You tend to know it. Well, it forms part of the Lambeth group, the pudding stone does. And I'm just focusing on this bit of Lambeth group down here, this brown patch, which is a place called Great Gaddesden, Dacorum, so just north of Hemel Hempstead. About 7-8 years ago, it was discovered a pudding stone mine back in 2015. It's an oddball story. There was a guy working at a estate agent's. One of the other guys in the estate agents was an amateur archaeologist come geologist, but was doing a master's degree in archaeology at Reading. And the young guy said to him, "Oh, we've got some holes in the family estate." He said, "Family, sounds a bit grand." He says, "Yeah, the family's been there since Henry VIII gave it to us," which is this place here, Great Gaddesden. There's Home Farm. And that, where it says Oak and Grove, is that. This is the LiDAR, so all the trees have been gone, the LiDAR image of the pits. There, Oak and Grove is that section there. When Mervyn Jones, who was the guy who was working on it, plus Chris Green, went in there, Chris was in his working career one of the county archaeologists for Hertfordshire. What they found was literally masses of discarded lumps of pudding stone. And when I say masses, we are talking, this was industrial. It was late Iron Age, early Roman era, and literally probably thousands of tons of pudding stone was quarried out of these holes and was turned into quern stones, grindstones. So these were portable querns for grinding corn, and literally they were they were taken from here and moved to another site where they were finished off. So it's written up 2023, Jones and Green in the Proceedings of the GA. It's worth having a look at it. It's a fascinating story. The other place here, that is this place Stablewood. That is still completely untouched. You don't go in there because that's where the local archery club has its practice. And if you're wearing a bright orange sort of pair of coveralls, then it's just a target. So that one has still never been dug over, that one there. So, brings me on to, if you like, the last part of the story, the Vale of St Albans, which is effectively where I live, down past Watford, heading down southwestwards into the Colne Valley, the River Colne. People are now looking at the distribution of swallow holes, big time, around the valley, just to get some idea of how much water may be disappearing into the chalk underneath and where it's going. There is in fact a guy currently doing a PhD at the University of Leeds, a guy called Dan Matthews, and Dan is really seriously looking at the rates of water flow in the subsurface across Hertfordshire through the chalk. So those holes we were talking about before really now start to have an impact. This was published by the BCGS team working here back in 2020, just to show you the number of sinkholes running. These are all the rivers coming down through the Chilterns. So let's say there's the, let me just work out, there's the River Chess, the River Misbourne, that's the Gade Bulbourne system, the River Ver through there. So all these are the rivers that flow into the River Colne that goes down towards the Thames as you head down towards Uxbridge. All the various holes, the sort of red dots, green dots, they're all various vintages of sinkholes in through the chalk where water is disappearing. And okay, the Ver, we highlighted the Ver there. It's just got this, the orange, the little triangles. We've got places where we're losing river as well, down into the chalk underneath. So we have to try and work out where the water's going. I put this in, I say this was done for the previous talk I was doing effectively. This is actually, I mean, it's got a place called Bricket Wood. There's the M1, there's the M25, and that's where I live. But all these red dots through here are all sinkholes. There are rapid flow pathways through the chalk, and what we're seeing is water that comes off the motorways is literally disappearing into these sinkholes over a period of about 3 weeks. It's taking to get through, sink through from the motorway, and it's literally showing up around these sinkholes when the BGS were dating the flow. Now, there is evidence, there is recorded evidence of subsurface flow. In the Hertfordshire book that we've got here, there's an example from 2007. There's St Albans, just to the north of St Albans, a little village called Sandridge. There was a pollution incident, and some bromate chemicals got into the chalk, and it showed up eventually over here in the River Lee. That's about 20 kilometres away. And subsequently, Affinity Water have spent an awful lot of money removing that bromate out of the water going down through the River Lee. Dan Matthews, who is currently doing his PhD, has been looking at this in some detail. There's Sandridge, where that original flood was up here. He's been looking at sinkholes in places. There's a place called Water End, just to the west of Potter's Bar, and timing flows to various boreholes that he has access to over in the northeast. And water is flowing subsurface. And he knows this because he's actually put tracers. So here's the sinkholes at Water End, and he's been measuring the number of hours it takes to get to these various boreholes. And he's either using what we call bacteriophages, which are like little they are virus type things, but they're sort of perfectly neutral, so you don't have to worry about them. But timing the number of days it takes to get from where he puts them into the sinkholes to where they show up in certain boreholes. And you can also use a chemical called fluorescein, and fluorescein does the same, and you can cross-check the timing. These things are flowing through where they peak and go through in the boreholes. And subsurface flow rates have been about 4.5 to 5 meters per day that he's been logging. Finally, I'm just going to whiz through this really quickly. You will have seen on the news loads of information about chalk streams having sewage pumped into them and being in a terrible state. A lot of them are. There's a lot of work being carried out by different people trying to clean these things up. This is a project that was launched around about 2022. Here's all the chalk streams we've been mentioning. The idea with this is, in fact, to turn off all the abstraction points, all the pumping stations that abstract water from the chalk and leave it in the rivers. And let it go down the rivers, but then when it gets down to like Heathrow, where all the big reservoirs are, Heathrow, you can take that water and pump it back to the houses upstream where you actually need the water. So from the public's point of view, one, they have water left in the rivers, so the rivers are flowing at a more normal level and potentially cleaner. And then obviously the water they need comes from further down. This is as I say, initiative called Chalk Streams First. It's still being pushed. It's still got to be convinced through to water company and government levels. So all I can say is watch this space. It may get there eventually. I'm going to skip through this bit quickly. We don't need that. One of the other things that a bit of work came out, 2019, another paper, it was in, I think it was in the PGA, may not have been. We get artesian wells, artesian boreholes in the Chilterns where water comes from depth under its own pressure. And in this paper by a group of geologists from Affinity Water, they mapped where the artesian wells were through the Chilterns. This one is actually one of these on the River Chess. And if you look at it, we've seen that trend before. That's this trend coming through here. So perhaps the folding that we've got in the chalk is actually affecting the pressure between the formations at depth and allowing this water pressure to build up in what would be the deeper formations, the Hollywell formation. And then when you've got a borehole through there, it just pierces that under hydrostatic pressure and it comes up. So we do get artesian wells, and they see, so we're beginning to see there is a reasoning behind some of the water flow that we get within the chalk. But we know that geology is complicated, so I'm just going to give you a taster of a project that I've just finished looking at the River Chess, which is, it's actually this one down here, just off the bottom corner. There's the River Chess. One thing I'll point out at this stage, it's got a funny bend in it. It goes round a right angle bend. Keep your eyes open for that, because that's an important part of the story. So that's the River Chess that we're going to look at just up there. Here's the River Chess, here's that right angle bend. And there is a pumping station. There is a borehole there which pumps water out for public use. So it's important that that is good clean water coming out. Now, just to show you, there's the River Chess again, there's that right angle bend. Over to the west, the southwest, look at all these red lines, all these faults running through here, and the one there going north-south. This was published 2022 by a guy called Adrian Marsh. He looked at the geology in the village where he lived, which is Chalfont-St Giles, and he recognised that there was a lot of faulting, and it was actually a lot of it was following river valleys or dry valleys, and his suggestion was that in fact probably a lot of the dry valleys that he sees in his area are probably underlain with faulting, but you can't see them because it's vegetated or there's houses built there. But look, the BGS, when they mapped in that area, say there's no faults in the Chess Valley. I have difficulty with this, you know, and you're looking at these sort of lines of dry valleys. And I've looked at the LiDAR that comes through here. My suggestion is that I think there's a series of north-south faults and probably a couple, and this one may well connect up with that, one of those big ones over in the Misbourne Valley. But I've still got to convince the guys at BGS that that is the case, because they're still not convinced. But let's go back to the geology of the Test Valley. The red stars that are on here are flow gauges. So they're actually measuring the flow of the river at any time, and they're in there 24 hours a day. And we've been doing a whole load of work looking at the Chess Valley, and there's the pumping station coming up. Those flow meters start here, they go here, 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 and here. And you'll notice if I follow any of these lines, the sort of flow, the rate of flow within the river climbs till it gets to this place called Valley Ford, and then it drops away. So if we go back, Valley Ford is this one here. So the peak of flow, of water flow down this river is here. As we get further south through here, there is less water in the river than there is up here. So I got asked, where's it going? And I've spent some time over the last 6 months trying to work out what is going on with the River Chess. There was a report on it back in 2006 by the Environment Agency, and they blamed Affinity Water for taking too much water out of the pumping station. But in fact, that wasn't the case. Affinity is restricted to 9 million litres a day, 9 megalitres. The blue line goes back to January 1995, and this is the maximum water that they've taken out of those boreholes at any time. They have never gone over their license agreement. So we know that there's never been more than 9 megalitres a day going out of the river at the pumping station. But when we look at the flow rates, and these are flow rates, if you like, the difference when we measure what's going on between here as a maximum and here as a minimum, and we do the maths on it, we find that we're losing anywhere between 10.4 megalitres a day and 25.8 megalitres a day. On average, it's about 19 million litres a day is disappearing. So this is a bit of a quandary. But what struck me when I was looking at the geology, this is the BGS digimap of the area, is have a look at these bright bits that go there, through there. Those are Proto-Thames gravels. When the River Thames was flowing through Hertfordshire, and before that Anglian ice, and it was going northwest eastwards across East Anglia, then these were the gravels that were being deposited by the River Thames. So that's the route of the Proto-Thames, heading up towards St Albans, which is off the top right of the screen. Route to the Proto-Thames going through. And this is a paper, Phil Gibbard at Cambridge provided me with this. Here are all those streams that flow into the River Colne and go southwestwards down to the Thames there. This is the Proto-Thames going out up near to Ipswich. These are all the tributaries that I think, yeah, there. So our friend the Chess, the Ver, would all have been flowing into the Proto-Thames prior to the Anglian ice sheet coming through. So the Anglian ice sheet, here it is. This is what it was like 450,000 years ago. Rivers like the Rhine and the Scheldt, the Meuse, were flowing into this huge lake. So was the Thames. There's the Thames going out that way. Eventually that lake overflowed and produced the Strait of Dover. But this is the one that we're interested in just here. What was going on with the Proto-Thames? Bit of a complicated map here, but here's the black line, just follow that through. That is the maximum ice advance. There's St Albans, where I live is just about here. And the Proto-Thames was this red line going through here. It got blocked just between St Albans and Watford. And where it got blocked, it started to build up a lake. Basically, it looks something like this. There's the ice sheet. Lake started to build up. Sand started to come in, form a delta in the lake, and eventually the river overflowed, went out down towards Uxbridge, and you get it joining up with the present-day River Thames. But that was the original Thames going through there. Then it got blocked and it got filled back to there. So it's a complicated story, but it makes sense. This is where it gets even worse. I put this together just to try and get some sort of order in what was going on in the River Chess. In summary, if we can, we had pre-glacial Proto-Thames gravels, and here are those gravels: Chorleywood gravel, Beaconsfield gravel, all building up as part of the pre-glacial Thames. You then get the glaciers coming through in the Anglian, extreme glacial phase, and you get a lake formed. And the glacial ice sheets cause a lake in the Vale of St. Albans, and we get what are called the Moor Mill clays. We know they are thick, sticky clays because they form my back garden. It's an absolute nightmare to try and dig over. But yeah, we have this layer of clay in the Vale of St. Albans, which is part of that lake system. And we then have uplift as post-glacial uplift, isostatic recovery, if you like, post-glacial isostatic uplift, and that the Chess Valley erodes down to its present level, which is 46 meters below where all those pre-glacial gravels are. So there's a complex story there, but it's something which actually does seem to tie together with the information we can find. I tried to look for other possible causes like sinkholes. There's a sinkhole in the Chess Valley. It's the only one. We've gone over the Chess Valley quite a number of times trying to locate anything that looks like a sinkhole, and that's the only one we've got. So water loss could be down sinkholes, only one visible, it's unlikely. Any sinkholes, I think, have been eroded by the river cutting down. We could have had permeable chalk, the chalk with all the holes in it, because the chalk rock sits right underneath the river through here as well. I think that's part of the story. I think there is some loss through the permeability. But I suspect it's far more complicated than that, and I think it's down to this much longer, complex geological history. There's probably at least 1 million years plus of Thames flow over the area, going way back before the ice glacial story came into it. And I think the chalk is probably so broken up, it's acting like a large-scale sponge. And if you calculate, I love it, when you go back to Olympic-sized swimming pools, okay? Basically, we're losing 4 Olympic-sized swimming pools worth of water every day on that stretch of the River Chess. So this is something that we've really, the report has just been submitted. We're still looking at this, but it's part of the complicated story of what's going on in the Chilterns. And I hope that's whistle-stop tour I've given you has literally given you some idea of some of the things that people are beginning to see that we've not seen before. And for an area where when you drive through it, you can't see any geology. There's hardly any outcrop. But if you do look, and you look at the sections carefully, then you start to come up with really quite a complex story. So, research goes on. Thanks for listening. That's all, folks. And if you've got any questions, I'll take whatever you can throw at me, and I'll try to answer them. Okay, thanks very much.
To give you the standard vote of thanks.
Thank you.
And apart from anything else, one of the things that occurred to me towards the end of your talk is here in the West Midlands, our water leaks away through people's poor quality piping. So Severn Trent often refer to leaky pipes. It seems in your neck of the woods that Mother Nature's to blame for the losses.
Oh, we get leaky pipes as well. Thames Valley have always got leaky pipes.
So can I just thank you on behalf of the Society for a wonderful talk in an area we know very little, to be honest, and covering such a range of topics to bring us up to speed on the current discoveries in your neck of the woods. So would you like to join me in thanking Haydon in the usual way?
Thank you. And the work goes on.